The object of this video is to build a temperature controller for use in beekeeping, but can be used for other heating projects. It is used to heat bulk containers of honey. This keeps in a liquid form, allows for using, bottling, and getting it out of the large containers. It can heat stacks of boxes holding honeycombs, provide auxiliary heat for beehives and new hives made from the splits of these big hives. These are called nukes. In the springtime, temperatures at night can get rather cold. The bees try to keep the larvae from getting chilled. Providing auxiliary heat hopefully will help them to keep the larvae alive and provide more rapid buildup. The criteria to build this, it should be inexpensive, control at set point with small drift, be weather resistant, safe as to shock protection, and not allowing high temperature on the heating pads. Use standard 115 volt AC power and provide up to 5 amperes to the heaters. A finished unit shown here is approximately $60. Controls at a set point plus or minus 1 degree, and exposed parts are covered with plastic. When used, it is inside a plastic container with leads running under the lid that can be fastened down. A lid is put down over the connectors and the wires and snapped into place. This will keep rain from getting underneath inside the box. The control parts are raised off the bottom of this container by the standoffs on the mounting board. Any water that would leak in around the top would run down, and then by punching small holes around the bottom, the water would just run out. That provides for some weather resistance, along with the lid not letting the water get in. As to the electrical protection, one thing you want to be sure of is to put a 3-prong plug on the unit during installation. The ground wire is hooked to the ground of the receptacle, and from the ground of the receptacle, a ground wire is run to the screw on the bottom of the solid state relay. The bottom of the solid state relay is metal. Also, the 115 volts that feeds this unit should be run through a ground fault receptacle. The parts needed to construct this controller are laid out on this whiteboard. There's a mounting board, a plastic box to allow the parts to be mounted in, screws, K-type thermocouple. The small black box is the controller, a couple electrical boxes, a receptacle box, extension, and a cover for the box. We have a solid state relay with its cover. After installation, you want to cover up the terminals with that plastic. There's a mechanical relay and its socket used for high temperature interlock. And of course, a receptacle and a receptacle cover. There's also wire glands to protect the wires going in and out of the boxes. The electrical cable that I buy for the receptacle is like a computer type cable that comes with 3 conductors and a special connector on one end. I cut that end off and then cut the plug end off at about 15 inches. Strip out the remaining wire to be used for hookup and the outside jacket to cover the metal braid of the thermocouple when I finish up. This will keep that metal braid off anything electrical that it might come in contact with. The main control parts are shown here. This is a solid state relay. It controls the electricity going to the heater to allow for good control by way of high-speed switching. If a mechanical relay was used, high-speed switching can make them fall apart over a period of time. The temperature controller has a 3 to 32 volt DC output on the back that runs to the input of the solid state relay to control the high-speed switching. Because a solid state relay generally would fail on, it could lose control. Even though the temperature controller says to shut off, it will not shut off. Therefore, the temperature would continue to increase, and to allow for protection against high temperature, we use a mechanical relay with contacts in series with the power output or the solid state relay. And so at high temperature, the controller has a relay output that'll turn off the mechanical relay. The solid state relay also has a plastic cover that should be put on the unit when in operation. K-type thermocouple was used to measure the temperature. The temperature controller runs a proportional integral differential control map. This allows for very precise control. This is commonly referred to as PID. This solid state relay we're using has a 24 to 380 volt AC on the power side. The control input is 3 to 32 volts DC and can run up to 25 amperes with a proper heatsink. I am not using a big heatsink on the bottom of this unit, and therefore I have limited the output of this to about 5 amperes. The total output of the package is limited by the relay contacts, by the solid state relay not using a big heatsink in the bottom, and the hookup wire. This basic control unit can be used to control a lot larger heating loads with the proper sizing of the output wiring and a much larger solid state relay mounted on proper heat sinking. Having gathered the parts, the next thing to do is get the parts ready for use. Cutting an 11 by 6.5 inch wide mounting board, round off the corners. Mount the 2 standoff sticks in the bottom. I staple mine on and make sure it fits in the box and clears the corners all the way down to the bottom of the box. The 2 electrical receptacle boxes will have to have the ears cut off. Small plastic tabs on the outside, clean them off. I use an oscillating saw to cut these ears off and clean up the sides. Cleaned up box would be for the temperature controller to mount in. There will be 4 holes drilled in these boxes. As far as the temperature controller box, on this Romex end, a gland is installed in this location for the thermocouple to go into, and on the opposite back side corner there's a gland installed for wires coming in to the temperature controller, the power and the alarm wires and so on. On the receptacle box, again 2 holes, one in the back corner and one in the Romex end for the 115 volt power coming in. These boxes will fit across from each other mounted on the board. In between the boxes, the other box will be inserted upside down and slide over the glands and cover up the solid state relay and the mechanical relay. The box used to cover up the relays can also have the on one side cut these channels out that were for holding the screws. These 2 channels on this side of the box will still remain. These will be reamed out and allow screws to be inserted down these channels to hold this box down onto the plate. Later, this box will also have side slots cut in it to allow it to slide down over the glands of the 2 boxes as such. The height is important on these glands, especially in the receptacle box. A cover goes on this and you want the cover to fit down tight, but you want to maintain the glands up as tight as possible to that cover plate. So the wires coming out here will clear the solid state relay. Take a steel ruler and mark down from the cover 1/2 inch and come in 1/2 inch from the back. That will be the point to drill a hole on this side of the receptacle box. The same on this end where the Romex comes in, measure down 1/2 inch and in 1/2 inch and mark that and drill the hole in this end for the 115 volt power going in the box. As far as the box that is used for the controller, measure up about 1 3/4 inches and in 1/2 inch from the side to drill that hole. Whenever you drill these holes, make sure you get in far enough that you clear the inside of the box, and you may have to cut small tips off the Romex knockouts to allow the washer and the nut and so forth to fit on the inside and get them tight. This is a box with the glands mounted. The receptacle would be mounted inside here. Again, these glands, the wires going in will not hit the receptacle on the sides. Having marked where the holes go on the different sides of the boxes, go ahead and drill a small 1/8 inch pilot hole where the glands go, and also on the back of the box drill a hole in this corner and a hole in this corner for the mounting screws to come down in from the inside. Do the same for the receptacle box. Don't get those screw hole or those holes too close to the edges, or you won't be able to get a screwdriver down inside to screw the screws down into the wood. To mark the square hole for the temperature controller to mount in a blank plate, look carefully on one side for concentric indentations in the plastic cover in 4 locations. Take a steel rule in the center of those and line up center to center and scribe a line up that side, and then the same with these two up that side. Measure in 1.25 inches from the other 2 sides and scribe a line across in the other direction in these 2 locations. Then take and drill pilot holes in 4 corners of the square, and also to get ready to drill out the mounting holes for the screws to hold this plate onto the adapter on down into the box that will hold the temperature controller. Once you drill the small holes, go ahead and drill a large 1/2 inch hole in the middle of the square. This will allow you to put a jigsaw in here and cut over and cut up to the holes in the 4 corners. It's now time to go ahead and mount the components on the mounting board. Lay the mounting board down in the big plastic box, set the temperature control box on the board, and make sure it clears the corner. Go ahead and put the screws in the bottom. These are number 6 1/2 inch sheet metal screws. Tighten the screws up. Take your center box, set on the mounting board, and your receptacle box and set it on the mounting board. Having got them lined up, you may want to take a pencil and mark where their boxes are going to fit. Remove the center box and go ahead and put the screws and mount the receptacle box. To finish getting things ready, take your cord. I use a computer type cord, 3-prong plug on one end. Take a pair of side cutters, cut off this large end, throw that away, measure about 15 inches from the plug back, cut the plug end off. This will become your power input cord. This other cord, take a sharp knife and start stripping the insulation off of one end. Having got some of the insulation started off and the wires hanging out, some of these wires will have strings around them, but you want to grab the wires and the insulation, and by pulling, just strip the outside jacket off the cables. After you get enough started, you may be able to pull them with your hand. Now you have the jacket, the cable, and the plug-in to use for your project. Keep this jacket. It can be put over the thermocouple braided shield to keep it from getting into electrical components, and also help to keep it from kinking. The wires and the plug-in should be stripped out on the ends, and then the leads tinned. You have to put these leads underneath screw terminals on the receptacles and so forth, and you don't want the ends fraying. So either lug them with lugs, electrical wire lugs, or tin the ends so you can bend them in loops and hook them around the connection screws. Having tinned the ends, take a couple of the wire glands and take the ends off. There's a little rubber gasket inside. Slide the end over the cable, and then slide that little gasket on so you can get it started over the end. Do the same for the thermocouple leads. Now, it's somewhat difficult getting the red and blue connectors that are in a thermocouple through these small holes of the wire glands. You just have to work at it and be careful not to mess them up. Also, take the extender and the cover box that covers the components, ream the holes to about 3/16 inch. The screws will have to go down through the cover plate, down through this extender into the mounting box. I use number 8 1.25" sheet metal screws to mount this controller and the extender down into the temperature controller box. Carefully start the rubber gaskets of the wire glands back into the fingers that stick out of the end of the unit, and pull yourself about a foot of cable through for the thermocouple, and pull the power plug wire through far enough to allow you to work on it. Later on you can pull them back down into the box. To get ready to wire up this unit, your black wire, take and cut about a foot off of it to give yourself an extra piece of black wire. Now you have all your tin leads and the extra black wire for a total of 4 wires. Keep the tin in the receptacle box and stick the wires through the wire gland, or extra black wire, that will go for the 110 volt power which feeds into the relay first. It'll be the one that's not tinned on this end. The other leads going over will have loops bent in them, along with the green and white leads of the power plug. The extra power plug lead and the bare copper wire, extra black wire, will be wire nutted together to provide power through to the power itself and into the temperature controller that needs power. Having all these threaded through, go ahead and put a wire nut on. Make sure these leads aren't too long. You want to get them on and get a good tight twist on that wire nut. Take the receptacle and you're going to loosen the screws on it and hook up the rest of the wires. Ground wire coming in from the plug will go on the ground wire, and also the green ground wire that's going to run on over to the solid state relay base will have to be put on. We're going to get the 2 loops on such that whenever you tighten the screw, that helps tighten the wires underneath it. Snug them up good and tight. You have a white wire coming in from the power plug. It goes underneath one of the neutral screws on the receptacle, and you have the neutral that's going to feed on over to the controller and relay, hooked onto the second neutral screw. After ensuring all the wires are good and tight and there's no whiskers sticking out anywhere, pull your cables down, your conductors out and down, and put the receptacle into the receptacle box. First wire to take to get ready to hook up would be the ground wire. Cut it off about 6 inches out from the wire gland. Bare the end about 1/2 inch, and I use the blue type wire lug with a fairly large hole in it. I use the number 6 to begin with, but if the wood gets stripped out going down through it and you don't get a good tight fit, you may have to use the number 8, and or take a stove bolt and put it down through and put a nut on the bottom. We want to make sure that ground wire is good and tight. Go ahead and slide the connector on, and with a lug tool, crimp it. Leaving the green wire this long allows you to tuck it down, and if you have to ever get into the receptacle, it gives you some wire to pull back to pull the receptacle up out of the box. Go ahead and put the screw and the ground wire into the bottom plate. Next, take the long black wire that effectively is hooked to the hot of the receptacle, cut it off about 4 inches, bare the end, and it'll fasten onto the solid state relay. This is a box type connector, and the wire can be stuck underneath that connector and then snug down good and tight on the black connector going to the receptacle. The other black wire is the 110 volt power coming in to feed the relay and the controller. To get the wire started on a relay and make sure you get it on the right connections, I take the relay loose from the mounting, and then you can look at the relay and determine which is the normally closed contacts and the commons. If necessary, you can take a meter and ring contacts out. Take the long black wire that you have left, cut a small jumper and about a 3-inch wire to go from jumper from here to here, and then from this to the hot on the solid state relay. The other side will get these two contacts jumper together. The power coming from the wire nut part, black wire, into this, and then also from this other side where the jumper is hooked into, put about a 6-inch black wire running from here that will slide through the wire gland into the temperature controller. Alright, this is what I wound up with the hot leads. Two normally closed jumper together, a 3 to 4 inch jumper coming off which will feed over to the solid state relay, the 115 volt power coming from the wire nut out into this, a jumper between here, and then off of this side run a 6-inch black connector into the temperature controller. The same principle will be applied to the white wire coming from the receptacle. It hooks on to a terminal on the bottom part of this socket for a neutral, and then also another white wire will be hooked on with it and run into the temperature controller. Coming from the temperature controller will be a black wire coming out to the other side of the coil. That black wire will be on the alarm contact of the temperature controller. Okay, now I've finished the two white wires underneath this terminal and a black wire off the other terminal for the coil. This black wire and the extra white wire will be slipped through the wire gland into the temperature controller. Make sure you have no whiskers on these wires. That could cause a short, and make sure you snug all the terminals down. Having slipped the wires through the wire gland, take the neutral wire. I generally tie a knot in it, but it's pretty hard to get it confused, but tie a knot in it. That's the power for the controller. And make sure you get the right black wire coming in, the one off the top terminals. Make sure you have it and tie a knot in it. That's the 110 volt providing power to the controller. The other black wire is the wire that goes out to the coil of the relay and is used to trip your high temperature shutdown. Having gotten everything remounted, make sure all the screws are good and tight. The 110 volt power from the relay output is hooked into the hot terminal of the solid state relay. The extra black and white wire length tucked back into the receptacle box. In this end you've got your hot and neutral with knots in them, and you have the black wire coming out to the coil of the high temperature alarm. Now you need two more conductors to feed the signal to the solid state relay. A red and yellow conductor, and you need about 6 inches of that. Now I've finished hooking up a red and yellow wire, red to the plus, yellow to the negative, on the solid state relay. Make sure these wires are down snug, you're not down on any insulation, and there's no whiskers hanging out. After make sure all that's tight, take your plastic cover for the solid state relay and put on those to cover them up. They slide down into the two mounting hole slots. Take the red and yellow wire and twist them together, and then insert them through the wire gland into the temperature controller. This finishes the wiring for the receptacle and for the relay and the solid state relay. The last thing to hook up is the temperature controller. Again, have the temperature controller mounted. Make sure the temperature controller is through the standoff. Having loosened all the screws necessary, looking at the thermocouple first, plus on 8, 7 on negative, I have found that the red is generally positive and the blue is negative. Thermocouples coming from different countries may have different color codes. Once this is hooked up and you get the power to the temperature controller, if you would stick the probe into a glass of cold water, if it went upscale, you knew these were reversed. You'd have to take the controller back out of the box and reverse these two wires. Now we've got all the wires ready to hooked in. One thing I didn't mention was, as you hook these wires up, make sure you twist them pretty tight as you can with your fingers, so the whiskers don't hang out. Alright, the plus and minus, I generally put the AC black on number 1. And the power must be jumpered from the 115 volt to the alarm contact, one side. Alright, now the black wire is hooked in to number 1 and jumpered to number 5. Tighten down, make sure there's no whiskers, and make sure you haven't tightened down on any insulation. Finally snug up with a regular screwdriver. We will now do the same thing with the plus and the red and yellow, similar to what I did with the black wires. Now I've gone far enough to check to ensure I have most of the wiring correct, except for the black wire going to the alarm contact. If you have an extra wire nut, screw on this bare conductor, and then we're going to plug the unit in and check some power going to the temperature controller. Alright, putting a wire nut on the wire, we assume it's going to the coil of the relay. It's not the hot wire. This is stuck loosely down into the case. We're actually ready to put power to this. If we've got everything hooked up correctly, the light should turn on. And if I put my hand on the temperature probe, if it's measuring correctly, it should go upscale. What you should do before you actually button this controller up is to take some electrician's tape and tape the steel braid that's going to remain inside the temperature control box. You do not want this steel braid getting on any 115 volt power. Now you can button the box up, pull some of the friction tape out through the wire gland, make sure that the thermocouple wire is off the one side, and then go ahead and put your screws in. Having snugged the screws down and make sure that they went in the holes, you have your thermocouple coming out. Slide the gland nut up over the thermocouple wire, make sure it's good and tight, and hopefully that tape that you put on there will help keep it from being pulled in and out of the box. This might be a good time to go ahead and uncurl the thermocouple leads and actually slip the jacket over them that you saved from the strip out of the cables. Alright, I've got the jacket on, starting a couple inches back from the thermocouple probe itself. The thermocouple probe I like to have is about 4 to 6 inches long. Has this flexible wire on it, the armor. Then I start the jacket that I peeled out from the electrical cable, put it on with a piece of tape about every 4 inches. When I ran out of that, I went ahead and took electrical tape and covered up the rest of the thermocouple lead. Now, the thermocouple lead probably doesn't have to be much more than 2 meters. The extra cable, you have to do something with it. I cover it completely up with electrician's tape and then take and wrap it around the thermocouple box just to get rid of the excess. I keep tape on it to keep it from being kinked and to keep it from touching anything electrical in the box. Meter and a half left. I take one of the wire ties that was holding the thermocouple in its big coil and just tie that wire tie around to keep it from getting away from me inside the box. And now for the finished product. Inside your box, there it is. Alright, this is a unit that we've been working on. Another thing I've done to it is cut a hole in the one box and put a clear plastic cover on it. This way you can look in and see the LEDs flashing on and off, and if you get the high temperature trip, there will be an LED on the coil that says it's tripped. When you get these units, they're generally programmed at the factory for degrees C. The differential part is turned off. The set points are at wide ranges. They will have to be or can be set down to what you would like to limit your spans to be adjusted to. To give you some idea how to set this, you push the set button, the yellow button, and hold it for approximately 10 seconds, and there you have alarm 1. I have this alarm 1 trip set for 120. Go to the next value, type 2 alarm. That's a high temperature alarm. There are about 7 or 8 different types of alarms. Alarm 2, which has no contact output other than LED on the faceplate, and its set point and what type of alarm it is. Here's the PUF. Now, a lot of times when you're using these thermocouples and so forth, you set a set point, say 100 degrees, and the temperature will indicate, say, 103 degrees, and not be exactly on set point. Even though it's controlling, the value of the thermocouple is not indicating the true set point. By adjusting this up and down, you can tune in at temperatures that you are interested in. Notice that if you wait too long, it'll go back to the set point and readout value. So let's say you're off 2 degrees, you can adjust this up or down to make the readout be the same as the set point and control at that value. Each thermocouple will be slightly off, and I generally set the thermocouples on 2 different ranges in the span I'm interested in. Like I may, if I'm controlling at 90 degrees, I will set a temperature at 50 degrees and check a temperature at 120 and kind of make it read as close as I can at each point. This is a type of thermocouple. This is a K. There's various symbols and other thermocouples that can be used, as well as RTD type platinum thermal detectors. This is the proportional band. The integration. In this case, the differential is turned off. You want to turn that on by, again, hitting the button and then turning it on to say 0 and setting it. Now, when you go to on a tune, the differential value will also be changed. Now it's for heating. This is where you change it to cooling if you like to have cooling. Hysteresis is how fast the relay is turning on and off. This is a different hysteresis than the alarm hysteresis. This is degrees C. You want to program that, hit the blue button, flip it to degrees Fahrenheit, enter the set button, and now you're in degrees Fahrenheit indication and set point. That's a lock. I don't lock it. That's the way it comes to the factory, not locked. And then you roll around and go back down through the unit again. Now to get back quickly, you can just hold your finger on the set button for up to 10 seconds. It'll go back to the value. In this case, the set point is 20 and the actual temperature right now is 68 degrees. I want to increase the temperature, push the blue button, index over, say I want to set 90 degrees, push the up button, and then hit the yellow set button. Now I have a set point of 90 degrees with 1 decimal point. Now there's another values by holding the 2 up and down keys together is a second. Low set point that I can set on this is 0 degrees. Upper set point 175.0 degrees. Now I think these come in like the value of 1200 for a K-type thermocouple. Hysteresis, now this hysteresis is the hysteresis of the number 1 alarm point. It's set for 30 degrees, so if I trip the upper alarm, I have to cool off 30 degrees before it would automatically reset the high temperature alarm, unless you pull the plug. Hysteresis 2, decimal point of 1, you could change the decimal point back to 0 or have a decimal point of 1. Some of these other values, now I roll back over again, so I'm rolling through. Now in order to get out of that, again, you would hold the button or just leave it go, but hold the button in for say 10 seconds and it should trip it back to the set point and output. When you first turn these on and you're setting a value like that and you're ready to control temperature, you want to make these things automatically tune. Alright, I have a heater here and I'm laying my thermocouple on the heater. I'm going to plug it in and you'll see the temperature start up. Alright, you can see the last value starting to change, 5, 6. Now, if I want to automatically tune this, you push the blue button down, it says AT on it, and hold it until a green LED comes on in that location. And you let it go for several minutes. The output will turn on, keep it on, and this will overshoot and come back, and then based on the overshoot and undershoot curves, the PID values are calculated automatically. each time you change your process, if you change the size of the heater, you take the thermocouple to control heat someplace else, and the heater is located in a tube or something like that, and you're blowing air over it to heat something up by air, you'd have to retune the controller for each set of circumstances that you're running. All right, I return now after the AT light has gone out and it's controlling plus or minus a degree Fahrenheit. Now, let's just see what the values are for the PID. Holding your set in for approximately 10 seconds, arm 1, the P is 13, I is 60, the D is 15, and what was for 0 whenever we first went back and set this, turned it off, and turned it back on. So the unit has essentially tuned itself. Now, so it's hunting for the set point. The other thing that we have to understand is the values can be too lively and try to adjust too quickly, even though we set for self-tuning. You may have to try this several times. Here I have a temperature controller set up controlling the temperature of a bucket. I had to go through the auto tune again. I have a set point of 100 degrees Fahrenheit, and I'm controlling plus or minus about 1/10 or 2/10 of a degree. There are actually 2 heaters strapped to this bucket, one on each side. Just the one heater has the thermocouple on it. In some cases I use these heaters just strapped to the side of the bucket. Other times some of them come with sticky back on them, and I stick them to a piece of aluminum. These will lay inside the beehives down, clear down the bottom. The sticky ones could be stuck to a bucket also, and but you still have to have a strap to hold the thermocouple onto the heating pad. This is a band type heater with the thermocouple being held against a band heater with a permanent magnet.